Hi there, this is the HiFi Audio CODEC Module I made for the Square Inch project contest. It is currently attached to the scope. I'll try to show you the main signals. The green wires are the clock signals. This is the BICK signal on the module, and it reads 1.4 megahertz. That's fine. This one here is the master clock. Let me increase. It's not perfect actually. Anyway, it reads 11.3026 something megahertz. It should be 1129, but that's fine anyway. And last but not least, this is the actual sampling frequency clock. It reads 44 kilohertz. Sorry for the focus, guys. And we have one issue. That is, the chip is working indeed. I'll show you that later. But come on. Okay, let's take the output for example. This is the data input towards the codec, and as you can see, the level is not right. If we zoom in and increase that, ta-da, we have a 1.41 circa megahertz signal, but it is not working at all. I mean, it looks more like noise for me. I have to understand why this happens. This happens anyway for every other sketch that I tried to run on the Teensy, even if it is not containing any HiFi Audio CODEC Module code whatsoever. Anyway, let's pass to the code here. This is the little sketch. Let me zoom in a bit because the focus is bad. I tried to attach two different sine waves to the two I2S output signals with patch cords here, and this is the interface that I made for the audio control for the AK4558. It's pretty basic. It enables the codec and sets the frequencies, but as you can imagine, there's no output at all. But we have something that tells us that the chip is indeed light. No, this is the control definition, the audio control class definition. It inherits from the audio control interface, the virtual class that Paul Stoffregen made for the audio library for the Teensy. By the way, this code here is part of a fork I made on GitHub, and this is the only method that these are the only 2 or 3 methods that I made to interface with the module. Okay, we have the main enable method here, which does everything that the datasheet suggests in order to properly set up the clocks and to enable the ADC and DAC modules, and that's it. There's something interesting here, that is, I made a method that reads all the available registers, that is 10 registers, from the codec as soon as the codec is powered on. and it saves them in a local variable which is the registers array. This allows me to edit locally the registers in the local copy I made, and so that I can run bitwise operations like this on the local replica, and then I can write the registers calling the local replica. That's neat. Also because I put some serial debug prints here, and the live test that I'm going to run is the following. If when I call the enable method and I receive all the standard values, the default values from these registers, it means that the codec is powered on and it is working correctly. So let's run the sketch. Not allowed. Ta-da! As we can see, starting setup start, power down is put high, that means that the power down is not, the chip is powered on. These are the default values for the registers. The last two are the DAC output automation level, that means no automation at all, and that's as the datasheet says, so this is working. Then we set the registers to the values that we need, and that's it. Hopefully next time I'll show you and I'll let you hear the codec working 100%. Okay? Bye.